Bright Tuty. Every student matters.
Let us move to these questions. In the given figure, side QP and RQ of triangle PQR are produced to point S and T respectively. So this angle SPR is 135, angle PQT is equal to angle 110 degrees. Find PRQ. So this is the angle that we need to find out. Now if I do this question in this diagram itself, then I can say this angle is a linear pair of this. Okay, so this will be 180 minus 135, that is 45. So this angle I have obtained as 45. Now this is an exterior angle, so it will be equal to sum of interior opposite angles. So this is 45. If this is theta, so I can say 110 will be equal to 45 plus theta. Hence theta is equal to 110 minus 45, that is 65. So the required angle, angle PRQ, is equal to theta, which is equal to 65 degrees. So this will be your answer. Now what are the concepts that I used here is that this angle, angle QPR plus angle SPR is equal to 180. Why? Because of linear pair. By using this, I could obtain angle QPR as 180 minus angle SPR, which is 135. So it is 45. Now once I obtained angle QPR, I used external angle property. That external angle 110 is equal to sum of interior opposite angles, that is 45 plus theta. Hence I obtained this result, angle PRQ equal to 65 degrees. Okay, so you write all these steps here. I told you in brief. Okay. In the given figure, angle X is 62 degrees, which we can see here. Angle XYZ, that is this complete angle is 54 degrees. If YO and ZO are the bisectors of angle XYZ and XZY, then we need to find angle OZY and YOZ. So let me redraw this diagram. This is X, this is Y, this is Z, and this is O. Okay, so these are equal angles. Why? Because this line is angle bisector. Similarly, these are equal angles. So if I name it alpha, this will also be alpha. If I name it beta, this will also be beta. Okay, by naming them, I mean that their measure is alpha and beta. Okay, angle XYZ, that is this complete angle, is given as 54 degrees. So I can say 2 alpha is equal to 54 degrees. Hence alpha is equal to 54 divided by 2, that is 27 degrees. Okay, and angle X is 62. So this angle is 62. Now applying angle sum property in triangle XYZ, angle X plus angle Y plus angle Z is equal to 180. Angle X I know is 62, angle Y I know is 54. So 62 plus 54 plus angle Z, it is equal to 180. So angle Z is equal to 180 minus 62 minus 54. 62 plus 54 is 116. Okay, when you subtract 116 from 180, it will give you 64 degrees. So angle Z, that is this complete angle, is 64 degrees. Now let us look at the question. We need to find angle OZY. Which angle is OZY? Beta. So to find beta, I can say twice of beta is equal to 64. hence beta is equal to 64 by 2, that is 32 degrees. So angle OZY, which is angle OZY, right? This is one of the answers. Angle YOZ, which is this angle. So I'll apply angle sum property in triangle YOZ. Angle sum property in triangle YOZ. I can say alpha plus beta plus the required angle, alpha plus beta plus the required angle, which is YOZ, it is equal to 180 degrees. Okay, alpha I know is half of 54, that is 27, and beta I know is half of 64, that is 32. So 27 plus 32 plus the required angle YOZ is equal to 180. So angle YOZ, it is equal to 180 minus, this is 59, right? So 180 minus 59 is 121. So this angle is 121 degrees. Okay, this angle is this one 27 and this angle is 32 degrees. So these are the angles which we required. Okay, I hope this question is clear to you. In the given figure, if AB is parallel to DE, this line AB is parallel to this line DE. Okay, this is AB and this meets at C here. This angle is given as 53 degrees, this angle is given as 35 degrees. These two lines are parallel. We need to find angle DCE. So we need to find this angle here. Let it be theta. Okay, I have named it as theta. Now you notice in the figure that AB is parallel to DE and AE is transversal. So I can say that this angle, which is angle CED, it is equal to this angle here, BAE, angle BAE. Why? Because these are alternate interior angles. Right? These angles are alternate interior angles. Hence, I can say this angle is also 35 degrees. Right? So I have obtained the measure of this angle as 35 degrees. Now I just have to apply angle sum property in this triangle. So applying, you write it complete, right? Angle sum property in triangle CDE. I can say that theta plus 53 plus 35, it is equal to 180 degrees. So theta is equal to 180 minus, what is their sum? It is 88, right? So 180 minus 88 will be equal to 92. Okay, so theta, that is the required angle DCE, is equal to 92 degrees, right? In the given figure, lines PQ and RS intersect at this point T such that angle PRT is equal to 40 degrees, which we can see in the figure. Angle RPT is also given as 95. Angle TSQ is 75. We need to find angle SQT. This question is very simple. We need to find this angle, so let's name it as theta. Right? Another unknown angle is this. Right? Let it be alpha. If this is alpha, this angle will also be alpha. Why? Because these are vertically opposite angles. So the first statement I am going to make here is that angle PTR is equal to angle STQ. Why? Vertically opposite angles. Okay, angle PTR equal to STQ. So let it be equal to alpha. Okay, so I start my question with this. Now, in triangle PTR, by angle sum property, I can say 95 plus 40 plus alpha is equal to 180. Then you write the reason, that angle sum property. Okay, so alpha I will obtain as 180 minus 40 minus 95. Okay, so this will be equal to 45, right? So alpha I obtained as 45. Now I'll apply angle sum property in this triangle, in triangle STQ. In triangle STQ, by applying angle sum property, I can say alpha plus 75 plus theta is 180. Alpha I already know is 45. So it is equal to 180. Hence theta is equal to 180 minus sum of these two, which is 120. Right? So 120. Hence it is equal to 60 degrees. So the required angle, that is this angle SQT, is 60 degrees. Okay, let's move ahead. In the given figure, PQ is perpendicular to PS. Okay, so this angle is 90 degrees. PQ is parallel to SR. So this line is parallel to SR. SQR is 28, so this angle is 28. QRT is 65, so this angle is 65. Find the values of x and y. Okay. So for this question, let me not write the explanations in detail. What I'll do is, I'll tell you verbally, then you write it yourself. So if PQ is parallel to ST, what I can say is that this angle, then you write it angle PQR, okay, is equal to angle QRT, and then give the reason that these are alternate interior angles. Okay, so PQ is parallel to ST and QR is transversal. By writing these, you can write that this angle, angle PQR, is equal to angle QRT, alternate interior angles. Hence x plus 28 is equal to 65. So x is equal to 65 minus 28, that is 37. Now I have obtained one of my answers, x is 37. Now I'll focus on this triangle here, in triangle PQS. In triangle PQS, I know two of the angles, so to know the third angle, I'll apply angle sum property in this triangle. By applying angle sum property, okay, so you write it full, angle sum property. I can say 90 plus this angle x, that is 37, plus y, it is equal to 180. So y is equal to 180 minus 90 minus 37. So this will be 90, 90 minus 37 will be 53. So y is 53, x is 37. Okay. So this was one of the ways to go about this question. You may find another way to find the solution, and it is very much possible in case of lines and angles that you can find more than one ways to solve a particular problem. And I would recommend that you try to solve each and every problem in multiple ways. That will open up your mind for various possibilities, right? Then you will not be dependent on one way to solve a particular problem. In the given figure, side QR of triangle PQR, read the problem carefully, right? And then look at the figure to relate it with the given figure. Now it is produced to point SQR, right? If the bisectors of, these are the bisectors. So if I name it as theta, this will be theta. If I name it as alpha, this will be alpha. Okay. I mean, if the measure of this angle is theta, this will also be theta because this line QT is bisector. Similarly, this RT is also bisector of angle PRS, right? Then prove that angle QTR is half of angle QPR. What is angle QTR? This is the angle QTR. So let us say this is angle 1, and which angle is angle QPR? This is angle QPR. So let's say this is angle 2. So I need to prove angle 1 is half of angle 2, right? Now, in triangle PQR, angle PRS is the exterior angle. This angle is the exterior angle to this triangle PQR. So I can say by exterior angle property that 2 alpha is equal to the sum of interior opposite angles, that is angle 2 plus 2 theta, right? This is one result that I obtained from this. So angle 2 is equal to 2 alpha minus 2 theta, or I can take 2 common, alpha minus theta. This is angle 2, right? Now let us look at this triangle. In triangle QTR, angle TRS, that is this angle, is exterior angle. Let me write it also. Angle TRS is exterior angle. In this triangle, I considered angle PRS as exterior angle. So this was exterior angle, right? This is exterior angle. Hence, it is equal to sum of interior opposite angles, which are theta and 1. So alpha in this triangle QTR is equal to theta plus angle 1. Okay. So from this I can say that angle 1 is equal to alpha minus theta, right? Now if this is 1 and this is 2, you can clearly see that angle 2 is twice of theta minus alpha and angle 1 is theta minus. Angle 2 is equal to alpha minus theta. So by comparing 1 and 2, or what you can do is you can replace this by angle 1. So I can say angle 2 is equal to twice of angle 1, hence proved. So this is a pretty simple question. The only thing that you need to take care, you write all these statements sequentially, and then always keep in mind which result you want to prove, right? In these questions, it is very difficult to do these questions wrongly because we already know our answer. We know where we need to reach, right? We just need to finalize the approach and then go about this question. So this was about the exercise here. I hope the questions are very clear to you and you find them easy now. Thank you.